might be nice to have a video recording of, did I say video recording? Of this day number 7 problem. You have a car. It's represented as going 1 meter is the unit of length. You have this nice little vector which describes if you started at 2, 0 and you went for 2 seconds in this velocity. It's called a velocity because it has a direction, and we can find the magnitude of it by taking the square root of the square of those parts. And so when I find my new position, I just take 2 plus 1.4, 0 plus 2 times 1. So that's going to give me 3.42. That is where I ended up after 2 seconds. We're asked to find out how far it is from 0. So essentially what you're doing is finding the magnitude of this if the tail is at the origin. So it's the square root of 3.4 squared plus 2 squared. Can someone tell me what that calculation is? What do you get? What's that? 3.9. Let's do one more. 4. I love it. So that's going to be how far? That'll be meters. So don't forget your units or it would be wrong. Because you are doing this in reality, so we have units on there. Next, find the speed of the car. Well, the speed, this is the part that controls the direction of the motion, which we call speed. So if we take the speed, will be the magnitude of 0.71, which is square root 0.7 squared plus 1 squared. And is that 1.2 meters per second? Okay. Any questions on that? Take your calculator. What's 3.94 divided by 2? It's not 1.2, is it?
1.97.
Yeah, the reason it's not is because we're not starting at 0, 0. We're ending at 3.4 up 2. That's where we're ending up at. But we're starting at 2, 0. So the reason this speed is lower is because if you found the distance from 3.42 to 2, 0. Let's do that real quick. 3.4 minus 2 is 1.4, and 2 minus 0 is 2. Would you take your calculators real quick? What's the square root of 1.4 squared plus 4? Just do that real quickly. What's the square root of 1.4 squared plus 4? It is 2.4 meters per second. And what's neat about that is it's going, because we're going back twice as far as this did, that's why it's twice as much. All right, next one. Obtain the equation of the car's path. So you started with xy, and you had 0, 2, and you had t times 0.71. I'm going to do just a double check here. Yep. I knew I was going to reverse something, and I did. So we'll get it. It is 2, 0, right? Yep. So this is 2, and this is 0. Obtain the equation, turn this into what we would call Cartesian form. Cartesian form. So you need it in parametric form first. That's what I wanted. Okay. So the first thing you do is put it in parametric form. X equal 2 plus 0.7t, and then y is equal to 0 plus t. So this should be a walk in the park for you because we just did this chapter where we convert this into non-parametric form. X is just going to be 2 plus 0.7 what? Y, because t is equal to y. So they want it in this form, so you have to do it that way. It's the law, x minus 0.7y equal 2. And there is your form of that path. Talk it out with me. Another vehicle, another miniature vehicle of a motorcycle starts at 0, 2 and travels along the straight line for a constant speed. The equation of the path is y equals 0.6x plus 2. Now, what you want to do is to find out where those lines intersect. You could turn those both into vector forms. I wouldn't. What I would do is I would say, I have these two equations, let's just solve for them. Okay? So, however you want to do it, you've got a y here. Why not? X minus 0.7. Put this right in there. So you'll get 0.6x plus 2. Go ahead and solve for x. So for those that have worked this out, you're going to get x minus 0.42x minus 1.4 equal 2. Yep, and so x minus 0.42x equal 3.4. And if you have 1 minus 0.42, that's going to be 0.58x is equal to 3.4. X is going to be 3.4 over 0.58. What is 3.4 over 0.58? 5 point what? Virginia, you said, was it 8.6?
86.
There it is. That is x. So the coordinate is 5.86. Now we need to find y. How are you going to find y? Put it into that equation. You can put it into this one right here. Probably yeah, that's a good one. I'd put it into this one though. Y is equal to 0.6 times x plus 2. X is 5.86. So you're going to get what for that? Yes, and that's right. Meters and meters. How many have that coordinate for the intersection? Great. That's a good way to do it. And then the last part, very last part. If a motorcycle left 0.02, at the same moment the car left 2.0, find the speed of the motorcycle. Now it's traveling in a line, and it starts at 0.2, and it ends up at 5.86, 5.52. So what would be really easy to do here? Super easy. Going from this point to this point, what could we find? Distance, right? They're both distances. So the distance traveled will be the square root of 5.86 minus 0 squared. Distance, change in x squared, change in y. 5.52 minus 2 squared. All right? And if you'd be so kind, give me that distance. What's that? 6.84, I like that. That's good. Now we want to know the speed of the motorcycle, so we'd like to know how long it took for the motorcycle to get to that intersection. So we have this equation here of the car, and we know that the car collided, right? We know that the car collided at 5.86, 5.52. So you can put that 5.86 for x, or you can put 5.52 in for y. I am going to put the 5.52 in for y, and say it's equal to 0 plus t. What's t equal to? 5.52, yeah. Well, just for fun, would we have gotten the same thing if we would have gone 5.86 equal 2 plus 0.7t. 3.86, what is 3.86 divided by 0.7? 5.52? Ah, all right. So then we're going to take the speed, is the distance over the time, 6.84 over 5.52, and you'll get your speed in meters per second, which should be 2 what? 4. So 1.2. And I don't know if you're right. I'm going to see. I'm feeling good about this, though. Here's the coordinate, 5.86, 5.52, and here's the time. 1.24. So that is the miniature car problem and motorcycle. You're going to, for Friday, and I'm going to check this, I want you to do 2, A, B, and C. Don't forget this angle. And do what you can to read, interpret. You can check your answers. The answers are there, but don't copy those.